Hello guys, good evening. Can you hear me? Yeah, hi Shraddha. Hello Ritu. Aditi, hello, how are you? Hello Dev. So where were we last class? Could you tell me what we were doing last class? I think we started those aldehyde, yeah, functional group, right? Okay, correct. Fine, okay. So we have discussed those functional groups from where we start the numbering, right? I guess. Let me see the check the PDF, last class PDF. Just a second, guys. Hmm. Did you solve that assignment? Alphabetical assignment? Alphabetic wala? Easy? Okay, so last class. Acha, we have discussed aldehyde. Okay. Okay, guys. Fine. Fine. So we were discussing about the, you know, the functional group, right? We were discussing about the functional group and all these functional group that I have given you, aldehyde, acid halide, cyanide, carboxylic acid, ester and amide. For all these functional group, we have discussed that we always start numbering from these carbon atom. Yes, that's what we have discussed. And last class we have discussed few examples of nomenclature of aldehyde. Okay, nomenclature of aldehyde. Bicyclo compound, we'll discuss it today. Okay, we'll discuss it today. So we'll finish this chapter today. Then you can again try those questions. You will get it. Okay, fine. So let's start, guys. So aldehyde we have discussed already. Now you see the nomenclature of acid halide. Acid halide. Acid halide, the functional group is this. We have C double bond OX. This is the functional group. We have acid halide functional group. C double bond OX means hydrogen of aldehyde you replace by halide ion. Halogen, that is X. Again, you see, like the rule we have, we again start numbering from this carbon atom. 1, and then we'll go this side. 2, 3, 4, and so on, depending upon the molecule. Yeah, we'll do Shraddha. We'll finish it. Okay? Okay. So this is the acid halide we have. Symbol you understood, C double bond OX. And the suffix of this functional group, suffix is oil halide, OYL, oil halide. Okay, we'll see some examples on this. Suppose the first one is HC double bond O Cl. Second one is double bond OCl. Third one is so this one, the name we have here, we have only one carbon atom, so it is methanoyl chloride. Methanoyl chloride. Correct. Very good. Methanoyl, not halide, it's chloride because Cl is mentioned. Got it, Shraddha? Cl is mentioned, so methanoyl halide, not chloride. Okay. Like this, you do these examples. I'll give you some more here. Try all these questions. One more I'll give you. The fifth one is this. Finish all, then we'll discuss. Okay, done? Fine. We'll start discussing this. So the second one is 2 carbon we have. So ethanoyl chloride. Ethanoyl chloride. For this one, 1, 2, 3. So 2-methyl propanoyl chloride. This one is 1, 2, 3, 4. So 2-cyclopropyl sorry, there's no hyphen here, but 2-ene 2-enoyl chloride, 1, 2, and 3. Prop 2-enoyl chloride. Any doubt in this? Okay. You can write one oil, but that is obvious here because we have to start the numbering from this carbon atom only. Srigori, okay? The rule is that only we have to start numbering from this carbon atom. So if you write one oil, it is not wrong, but if you do not write also, it's fine. Better if you do not write, okay? Because it is understood. The rule is that only. Okay, next. The next functional group we have is cyanide. Cyanide functional group, it is Cn, and its suffix is nitrile. Remember, all these functional group, we always start numbering from the carbon atom of the function. For example, you see this CH3CN. Try all these. The first one I'll do and then you can try. Okay. The first one is 1 and 2 carbon atom. So it is ethane nitrile. And we'll write this terminal E here. Ethane nitrile. Then you try. Okay, done? All of you? Okay. So this one is 1, 2, and 3. So it is 2-methyl propane nitrile. Here 1, 2, 3, 4, and 5. So again 2-ethyl 3-propyl pent pent 4-ene nitrile. How many of you done the third one? Okay. 1, 2, 3, 4, 5, 6, 7. So what do we write in this one? Hepta 3, 5. Hepta 3, 5 diene nitrile. 1, 2, 2-cyclohexyl ethane nitrile. 1, 2, 3, 4, and 5. So 3-bromo, 4-cyclopropyl, 4-methyl pentane nitrile. Is it correct? All of you, tell me. Yeah, in the fifth one, the ring is bigger, but the side chain contains functional group, right? So parent chain is this one, the chain which contains functional group. Okay, some of you have doubt in this one. 1, 2, 3, 4, 5, 6 carbon atom here. But here we have double bond here. So we'll give priority to the double bond. We always take double bond in the parent chain. Any other doubt? No? Okay. Next is ester. Ester, the functional group is this. Okay, and the name of this compound, we write alkyl alkanoate. Alkyl alkanoate. You see here, there are two alkyl groups present, this one and this one. Right. So which one should go with alkyl and which one should go with alkanoate? Okay. This is important to keep in mind. You see the alkyl group which is attached to oxygen, that alkyl group will come over here. Alkyl part we get from this. right? Alkanoid part will get from the other carbon atom, this one, right? So this is alkyl and this is alkanoid. So alkyl, alkanoid. And we'll start numbering from the carbon atom of the functional group, which is this 1, 2, 3, and like this. This side we have to go, not this side. Okay, let's see some example here. CH3, C double bond O, OMe. What is the name of this compound? What is this? Molybdenum. What is? It's not molybdenum. This Me in organic chemistry, Me stands for methyl, CH3. Et stands for ethyl. Okay, CH2, CH3. This is the two terms you must remember, Me and Et. Right, so we see first of all, the parent chain is this 1, 2, and this is attached with the oxygen. So with this we'll write alkyl. So this becomes methyl. And we have 2 carbon here. So methyl ethanoid. Do this one. Oh, just a second. It is chlorine. Do all these. Done, all of you? Okay. So this one is methyl propanoate. This one is 1, 2, 3, 4, and 1 and 2. Right? So we'll write here 1 bromo ethyl. which is this part, 1 bromoethyl, and this is 3 chloro but 2 enoate. Okay, and this one is 1 chloroethyl, 3 bromo but 2 enoate. Okay, now you see this one, I have written here chloro first and then bromo. Here it is bromo chlorophine, right? So we do not consider here alphabetical sequence of this part and this part. We always write down this part first, whether it comes alphabetically or not. Are you getting it? We always write down the alkyl part first. No, it's not. That's what I'm talking about, Ritu. We always write down the alkyl part first, right? Whether it is coming first alphabetically or not. Okay, that is why I've given you these two examples. This one is methyl methanoate. Okay, next example. This one you try. Write down the name of these compounds. Just a second, I'm coming. Okay, finish this. Okay, done. Okay, so the first one is, this part is ethynyl. Okay, so the name is ethynyl 1, 2, 3. Prop 2 enoate. Okay, this group is phenyl group. So it is phenyl ethanoate. Okay, this one is 1, 2, and 3. Cyclo prop 2 enyl 1, 2, 3, 4. But 2 enoate. Any doubt in this? No. Phenyl group, will discuss it separately, not benzyl. This is phenyl group, this ring is phenyl. So phenyl ethanoate. Now in this one only, one more example we'll see. When two esters are together, write down this note. When two esters are together, then the name will be dialkyl alkane dioate. Like this we write. Dialkyl alkane dioate. Correct? So, for example, if the molecule is CS3, O C double bond O. And this side we have C double bond O, OCS3. Okay? See, the alkyl which is attached to the oxygen is the alkyl part, right? So methyl here, and here we have methyl. Methyl, methyl. So we write it as dimethyl. When two ester, same molecule we have here. So dimethyl, and here we have 2 carbon atom, right? So it is ethane dioate. ANE here. That won't be the double ester, I think. You should not have any alkyl group between the 2 C double bond O group. Symmetrical, we can take this side, alkyl group may be different. Means methyl ethyl is possible. Okay, so this is ester. Now the another functional group is amide. The amide functional group, the suffix is amide itself. Yes, we should write that in alphabetical order. Correct, Gayatri. Okay. Amide, the functional group is this. R C double bond O NH2. This functional group is amide. Means from aldehyde you remove hydrogen and attach NH2. You'll get amide. Suffix for this is amide itself. See this example. CS3 C double bond O NH2. One more thing here, that we again will start numbering from this carbon atom. One, and then this side we have to go. CS3 C double bond O NHCS3. C double bond O NBrCl. ET C double bond O NCH3 ET. Double bond O. Try this. Okay, done. Okay, ethylamide, butaneamide. No, it's not, guys. Okay, I'll explain this. See what happens. The first one is simple, 1, 2. So it is ethanamide, right? Ethanamide without any gap will rise and terminal E will be omitted. Ethanamide. Now this is again ethane, but this methyl is attached to the nitrogen atom. So what will write? N methyl ethanamide. Any doubt in this? Tell me. Right? So N methyl means what? that the methyl group is attached to N, that is the nitrogen atom. That is the meaning of N-methyl. Got it? So that is how we'll do the nomenclature of amide. Try others. I guess all of you have got the wrong one previously. Now you try others. N-bromo, N-chloroethanamide. Yeah, it's correct. Capital N, Kiran. The nitrogen wala N will be capital here. N-ethyl, N-methyl propanamide. Stuti, correct. But N, after N, you should have hyphen and then methyl. Okay. Right. Ritu got it. Kiran, correct. The last one, tell me. N-ethinyl, 1, 2, 3, 3-bromo, butanamide. Is it propane? N-ethinyl, 3-bromo, butanamide. Okay. See, the last one I'll do here. N-ethinyl, 3, 1, 2, 3. Three bromo, butanamide. Okay. Just a second, Archit. All of you have done this? Correct? But here you see one change we have to do. This bromo alphabetically come first, then ethinyl. Then we should write this 3-bromo first, 3-bromo first, and N-ethinyl after that. Correct, Archit? So the name of this compound is what? This one is wrong. The correct one is 3-bromo, then N-ethinyl, butanamide. Okay. So when you have written this name, don't rub this. Okay. Just you cross like this or just put a line like this, so that once when you revise this, you'll get to know that what discussion we have had, right? And what is the important thing you should keep in mind. Got it? Okay. The another one is carboxylic acid. RC double bond O OH, and we'll start numbering from this carbon atom.
Thank you.
What is the suffix for this? Yeah.
தொட்டு சாப்பிடுறதுக்கு ஏதாச்சும் இருக்காமா?
What happened
பிஸ்கட்
there?
இருக்கு பாருங்க. மாமா மாமா.
Kiran, you mute yourself.
நான் தொடர்ந்து பாக்குறேன்
क्या बोल रहा है?
இருக்குது ரெடி பண்ண நான் வந்து கிளவுட்ல போட்டு வச்சிருந்தேன் நான் சொல்றது கேளு இது ஓபன் தான் கிளவுட்ல போட்டுதான்
Oic acid. Correct. Example we see. Name of these compounds. Finish. Okay. First one is 1, 2, 3, 4. So it is simply butanoic acid. This one is 1, 2, 3, 4, and 5. So 3-cyclopropyl, 3-cyclopropyl, 2-methyl, pent, 4-enoic acid. Just a second. Okay, guys, sorry. So, okay. So, any doubt in this? No, correct? The third one is easy. 2,2-dimethyl propanoic acid. What about the last one? I'm not doing this one. I guess all of you have done this. The last one is 1, 2, 3, 4, 5, and 6. Okay. So we'll write 2 bromomethyl 3-chloro hex 4-enoic acid. Got it? 2 bromomethyl 3-chloro chlorohex 4-enoic acid. Any doubt? Anyone? Any doubt we have till here? Tell me. All of you, quickly reply. You can type CLR quickly, guys. Okay. No, Harsha, 2 then 1 bromomethyl is not required because this methyl has only 1 carbon. So when you say bromomethyl, it means that bromine is attached with 1 single carbon only. So that is not required. But if you write, it's not wrong also. Okay. So guys, one thing here quickly, we have discussed whatever functional group we have discussed now, from aldehyde to last class we have done aldehyde, and now we have done from aldehyde to carboxylic acid. Now one thing is common in all these functional groups that we have discussed from aldehyde to carboxylic acid. What is a common thing? Could you tell me, anyone? That's very good, Bhumika. That we always start numbering from the functional group carbon, right? The carbon atom of the functional group. This is the point you have to keep in mind. Whatever functional group we have done from aldehyde to carboxylic acid, we always start numbering from the carbon atom of the functional group. Clear? Will you keep this in mind? That's why I have done this all together. Correct. Okay. Now there are a few more functional group left. Like for example, I will take this one, ketone. Ketone functional group is this, C double bond O, and the suffix for this is -one. For example, what is the name of this compound? Harshini, prop-2-on you cannot say. Propane, propanone you can say, right? So 2-propanone or propane 2-on. Okay, Dev is saying second one is not a ketone, it's an aldehyde. What about you, Dhruti? You are saying it is a butanone. Is it correct, Dhruti? Think about it once. Yes, Harshini, got it. It's not ketone, right? So that is why the name of this is an aldehydes, 1, 2, 3, 4. So butane null. Like some of you have written butanone directly, right? Butanone, right? So I can bet you on this, you will have this as an option in the question. You will get this as an option, right? So in hurry, you will obviously take this out and then you'll get negative marks, okay? So please take care of all these things, okay? It's not a butanone, it is an aldehyde, so butanol. This molecule is, you can write 2-propanone or propane 2-one, both are same thing. This one is 1, 2, 3, 4. The numbering is this 1, 2, 3, 4, 5. So pent 3-ene 2-one. Is this correct? Last one, tell me. Yes. Again, this terminal E we have to drop. Now I think you have understood all these stuffs. You can go a bit fast also. Right? You see this molecule, guys, it is a very important compound. This molecule, the common name of this is acetone. You must remember this. Common name is acetone. CS3COCS3. This is acetone, right? Could you tell me the name of this one? Okay. So this, the common name is acetone, like I said. And this one is what we should write here. Prop correct? Okay. So you see, one thing I would like to discuss over here. Have you heard isomerism? What is isomerism? We have discussed. We have little bit we have discussed. No, first class. Isomers you have studied, right? 10th grade, correct. Have you heard about equilibrium? Equilibrium. What is an equilibrium state? Okay, not equilibrium state is not the most stable state. Let it be as. So here these two compounds are in equilibrium actually. These two compounds are in equilibrium. And the kind of equilibrium here we call it as dynamic equilibrium. Dynamic equilibrium. And if you observe, the molecular formula of the two compound is same. Right? The molecular formula of the two compound is same. Right? So these two are isomers also. What kind of isomers they have? Structural. Have you heard about functional? Yes, functional isomers. But here what happens, you see, these are the special type of isomers in which a special type of isomerism in which the two isomers are in dynamic equilibrium with each other. And this kind of isomers, we call it as tautomers. We call it as tautomers. So tautomers is a special kind of functional isomers where the two isomers are in dynamic equilibrium with each other. Right? This is one relation we have. Tautomers, again, we'll study all these things in detail in a chapter called isomerism. Correct? Is it clear? You know what is dynamic equilibrium? What is the other type of equilibrium we have? Static. Okay. So this is a dynamic equilibrium we have here we have. Tautomers, let it be. These two are tautomers of each other. That is what we say. These two are tautomers of each other. Actually, this is converting into this, and this is also converting into this. This, the name of this is acetone, right? This means what? Suppose in a bottle, if you take only acetone into this bottle, okay, my drawing is not that good. I'm just trying to do my best. This is actually my best. Okay, so you can laugh if you want. Okay, so that is, anyways. So this is, suppose we have bottle, right? And in this we have taken acetone, pure acetone. Okay, so what happens after some time, if you see the percentage composition of this, acetone is not 100% after some time. Initially, when you have taken acetone, this will be 100% because there is no, mixture we have. We have only acetone present. So composition of acetone initially is 100%. Now, after some time, if you calculate the composition of acetone, it won't be 100%. It will be lesser than 100%. Could be anything, but lesser than 100%. Why? Because some part of acetone converted into this form, right? And this, you see the name of this compound, generally we call it as enol, en and all. So this is the enol form. And since we have keto here, so this is keto form. And this process by which this acetone converts into this enol, this process is tautomerism. And the two compounds that involves in tautomerism are called tautomers. So acetone and prop 1-en-2-ol are tautomers of each other. Little bit, are you getting it? You don't have to understand it fully, right? No, there is a dynamic, static, dynamic, both kinds of equilibrium we have. No. No, see, Bhumika, don't try to relate this with other isomerism. This is the one word I use. That is, this is a special type of isomerism in which the two isomers involve in dynamic equilibrium. Okay. Don't try to go into depth of all this because you won't get it now. Right? So let it be just a small, and again, one term I have introduced to you. This is the one term. When we discuss isomerism, we'll discuss all these things in details, right? It depends again, Harshini. It depends. If enol form is very stable, far more stable than keto form, then keto converts into enol completely, 100%. So it depends upon the stability of the two, this one and this one. Depends upon the stability. The one which is more stable, that will exist more. Their composition will be more. Suppose you have started with acetone, 100%. But if this form is more stable, right, then the composition of this will be more in the mixture. And you do not ask me, sir, which one is more stable. For that, you have to understand many things to understand the stability of the two compounds. Okay. So by the end of this year, 11th grade, you will get to know that how to compare the stability of these compounds. Okay. We'll discuss all those concepts. Clear, guys? Can I move on from this? Thank you so much. Okay, right. So this is a ketone, right? And in this functional group, yes, Kiran, tell me. Kiran, I'm waiting. What is the next to acetone 100%? Where 100%? Acha, this one, this one, this one. This one, this one. Acha, this one. Okay. So this one, Kiran, it is less than 100%. But ignore this. Nothing is, it is not required. Let it be. Forget it. I want to give you a little bit of idea of this competitive exams. Okay, a little bit of touch I want to give you. And you want to know everything. I'm like, so all of you, let it be. We'll discuss this later. Okay, I'm joking. Don't take this seriously, all of you. Okay. So little bit of one new term you have understood now. That is tautomers. Okay. The tautomers, keep that in mind. Detailed concept, everything we'll discuss when it comes to the when we'll go to that particular chapter. Correct? So let it be. Fine. So the next is we have discussed this one, ketone. One more functional group we have, and that is ether. You know what is ether? Ether is this. Right. Alkoxy alkane. Suffix is what? Alkoxy alkane. Where here we have R and R, alkoxy alkane. So the smaller alkyl group goes with this alkoxy, because again you see both sides we have alkyl group, right? So the smaller one goes with alkoxy part. For example, what is the name of this compound? CS3OCS3. Tell me. ETOCS3. Methoxymethane, the first one, and methoxyethane, the second one. Okay, so methoxymethane, the first one, and methoxyethane, the second one. This one is 2-methyl ethoxy propane. Any doubt? No. You know the common name of this compound is dimethyl ether. Common name is this. Dimethyl ether is the common name. For this one, it is ethyl methyl ether. Alphabetically, we'll write ethyl methyl ether. Common name. This one is 2-methyl ethyl propyl ether. Which one, Madhumati? 2-methyl ethoxypropanes. Correct? No. Methyl, the position is at, acha, it is first carbon only. Correct, not required. My bad. It is at first carbon only. So methyl ethoxypropane. Correct. Okay, 1-methyl or methyl, 1-methyl you write, that would be better. Because we have 2 carbon atoms. So we should mention the position here. So 1-methyl ethoxypropane. Yes, Madhumati, correct. Fine. Okay. Now one last functional group we have, that is anhydride. Write down, it is the combination of, so one more we have after this. Write down, anhydride, it is the combination of 2 acid. It is the combination of 2 acid. And the suffix here is oic anhydride. The symbol is this. And the suffix is oic anhydride. Okay, oic anhydride. So the name here, first of all, you see how anhydride forms. Okay, consider this reaction: CH3 C double bond O OH. When I say in organic chemistry acid, it means it is carboxylic acid. Now the 2 molecules of carboxylic acid we are heating. So what happens in this, that from one molecule H plus and another molecule OH minus, that combines, forms H2O, which goes out, and this oxygen combines with this carbon. So the product here we get is CH3 C double bond O, OC double bond O, CH3. No, it's not ester. It's not ester. Achha, ester we haven't done. We'll do that also. Wait. Okay. So it is this compound. Now you see in this compound, this bond is there. So we call it as anhydride. Now the name of this compound is what? Since you see here, it is formed by, what is the name of this compound? Could you tell me? Guys, ester we haven't done. Just a second. I think we have done ester, no? Esther, we have done. You see this? We have done, Esther. Huh. What is the name of this compound? Ethanoic acid. Right? Not methanoic. It is ethanoic acid. 2 carbon atom. No. It is ethanoic acid. Hence, since the anhydride forms here by the combination of 2 ethanoic acid, then the name of this compound is ethanoic anhydride. Okay, let's see this example. We have HC double bond O, OC double bond O, CS3. So this side we have 2 carbon, it is eth, it is meth. Then we'll write ethanoic, methanoic anhydride. Clear? Yes, yes, we have to. It follows alphabetical sequence right down there. Okay. Do these 2 questions. The name of this compound is 1, 2, 3, and this is 1 and 2. So this is ethanoic alphabetically, and this one is prop 2 enoic anhydride. This one is 1, 2, 3. So prop 1 2 eth.
Continue.
2 cyclobutyl ethanoic propanoic anhydride. Correct. Understood? Okay. Now one last functional group is amine. Amine is NH2, RNH2 basically, and suffix is amine itself. So write down the name of this compound, CH3NH2. NH2. NH2Br. CH3NH. CH2CH3. CH3CH2 NCH3 CH3 CH3. First one I'll do, it's methane amine, so it's methanamine. Do the other questions. No, methanamine, the first one. Yes, if anything is substituted there instead of hydrogen, if anything is there, then we'll write N-methyl, N-ethyl, whatever, accordingly. Yes, it's correct. Done? Okay. The second one, the name of this compound is 1, 2, 3, and 4. So it is butane 2 amine. butane 2 amine, and the terminal E we have to drop this E. This one is 1, 2, 3, 4, 5, 6. So 5 bromo hexane 2 amine. Right? 5 bromo hexane 2 amine. Now for this one it is 1 and 2. N-methyl, because N and CH3 is attached. N-methyl ethanamine. And for this one, it is N-ethyl N-methyl propanamine. Tell me, any doubt? Any doubt in this? Yes, what happened in the fifth one, Ruchita? See, in the fifth one, the longest chain is this. 1, 2, 3. Here we have only one carbon. Here we have one methyl group. So if the same molecule, if I draw this way, then you won't have any doubt. Parent chain is this. Propane 2 amine we should write. Propane 2 amine here. The number I have missed. Okay. At second carbon will have this. No, second carbon will have this. So N-ethyl, N-methyl, propane 2 amine. Yeah, it is propane 2 amine, correct. Got it done? Srigori understood? Ruchita understood? Okay. Now we have done all the functional groups. Now the molecule which has more than one functional group. So if the molecule has more than one functional group, okay, then the given functional group in the molecules, out of those functional groups, one functional group becomes the primary functional group. Primary functional group, which is in short, we write it as PFG. And the other functional groups are secondary. Secondary functional group, that is SFG. Clear? Primary and secondary function. Now, in the molecule, to write down the IUPAC name, will have the suffix of primary functional group. Means suffix will write of primary functional group. For secondary functional group, will write prefix, not suffix. This secondary functional group can be one or more than one. It's possible. But the primary functional group will only be one. It is not possible that two molecules, two functional groups are primary functional. It's not possible. How do we define which one is primary and which one is secondary? Based on what? Based on priority. Any doubt? So we should know the priority order of the functional group. Yes or no? Correct? So based on the priority, suppose we have 2-3 different functional groups present in the molecule. So the one which has the highest priority becomes the primary functional group, and we write the suffix of primary functional group for the IUPAC name of the compound. Right? Other one is secondary functional. So just a second, just let me finish this. Okay. So I have already drawn a table of the priority of functional group. Okay. So you can copy this down. Okay. This is the table we have. You write it down as it is. I have written this in the priority order from highest to lowest priority. This is one slide, and after this we have one more like this. Okay, so you copy down this, all of you, and then let me know. I'll show you the other slide quickly. You copy this down. On the top you write down, priority order. Let me know once you finish this. Finished? Okay, let others also write. Just few more minutes. See here, I have written carboxylic acid suffix is carboxylic acid also, carboxymide, carbaldehyde. So when we use these suffix, that we have to discuss. We will discuss that rule separately. Okay, so that's why I have written it here. The last one is thiol. Thiol is SH, mercapto thiol, MERCAPTO, mercapto thiol. Okay, done? Vaishnavi, fast. Which case can carboxylic acid give a prefix? We'll see that. Wait, Ruchita. Okay, all of you have done? Okay. The next is this. Copy this down. 16th one, there is no suffix for halogen. Alkyl halide generally we write. Okay. For halogen atom, suppose we have CH3, CH2, Cl. We'll write ethyl chloride. Okay, so you can write alkyl chloride for that. Okay, done. Yes, yes. Nitroalkane we write no. CH3, CH2, NO2, ethyl, nitroethane. That's how we write. We'll see some examples on this and then we'll take a break. Okay, we'll finish it off. Done, all of you guys? Yes. Alkane is not alkyl, it is alkynyl. Alkyl, alkanyl you can write. We write no, alkyl halide. That is what it is. Finish. Okay. Now you see some examples here. Mostly we have already done. We have already done many examples of nomenclature. Just we'll see 2, 3 for polyfunctional group, more than one functional group if we have. Okay, for example, see this one. Done, all of you? Okay. Primary functional group is this: 1, 2, 3, 4, 5, and 6. So 5 oxohexanoic acid. Hexanoic acid. This one, this is the primary functional group: 1, 2, 3, 4, 5, 6. Right? So hydroxy and this one, 3 hydroxy, 2 methyl. Hydroxy, 2 methyl, hex, 4-ene nitride. Okay, this one, 1 and 2. So 2 cyano. Consider this, we are not taking in the parent chain. Keep that in mind, okay? Because when we write cyano, it means we have included one carbon atom here, right? So 2 cyano, 2 hydroxy, ethanoic acid. Okay, so if you don't take this cyano here, then we'll write propanoic. If you write here propanoic, then 3 carbon here, and for cyano 1 more carbon. So we'll have 4 carbon there in that case. But we have only 3. So 2 cyano, 1 carbon we have here. Ethanoic, 2 carbon we have here. The name of the compound is this. Now in this case, what happens? The name of this compound would be 1, 2, 3, 4, 5. So at third position, we have this group present. So we'll write down the prefix of this. What is the prefix of COOH? 3 carboxy, 2 methyl, pent 1,5 dioic acid. Pentane 1,5 dioic acid. Okay, so 3. Ruchita, you have asked this, right? Sorry. 3 carboxy, 2 methyl, pentane 1,5 dioic acid. Okay, fine. So like this, we can do the numbering of these polyfunctional group compounds. Just 2, 3, some miscellaneous examples we have here. I'll just show you here and then we'll take a break. Just 5 more minutes maximum I'll take, guys. Suppose we have a compound like this, a ring and oxygen is present here like this. So we have total 6 atom here, including this oxygen. So for oxygen, we'll write the name here, oxa. Oxacyclohexane. So for oxygen, we'll write oxa. If you have sulfur here, then the same thing we'll write thia. Thiacyclohexane. If you have nitrogen present in the ring like this, so for nitrogen, we'll write aza. Azacyclohexane. If the compound is an open chain compound, for example, NH2CH, 2CH2, NH, CH2, CH3, right? In this case, we'll prefer the numbering to nitrogen atom than the carbon atom. So 1, 2, 3, 4, 5, 6. Lowest sum rule will follow for nitrogen atom. So total 6 atom we have here. So we'll write here 1, 4 diaza hexane. Diazahexane. Similarly, the last one we have, if you have oxygen present, CH3O, CH2, CH2O, CH2, CH2, OCH3. Could you tell me the name of this? Only nonane. 2, 5, 8 trioxanonane. 2, 5, 8 trioxanonane. Okay, the last one is this. Tell me the name of this compound. Amide is this. C double bond O NH2 is amide. Aza is nitrogen present in between the compound. Like this, both sides we have carbon atom. Suppose in the open chain, if you have only one nitrogen, then that will be N-methyl methenamine, like this one. But if you have more than one nitrogen, then we'll go by this, diaza. In the ring, there is no confusion. Got it? The last one, what is the name? See, the numbering will start from this carbon 1, 2, 3, 4, 5, 6. So at third position, what we have? Third position, we have methyl carboxy. Sorry, carboxymethyl. Because methyl is the group which is attached to the parent chain, no? So 3 carboxymethyl hexane 1,6, 1,6 dioic acid. Did you get it? It's not methylidine. Methylidine when CH2 attached with double bond. It's not a double bond. It's single bond CH2 COOH. It means it is the substituents there, and COOH is the another substituents of that carbon atom. Got it? Fine, we'll take a break now. We'll resume the class at 6:30. Okay, take a break, guys. Hello guys, can you hear me? Yeah. Okay, fine. Now, okay, nomenclature. Now you see there's the basic rule that we have discussed here. Some miscellaneous examples and rules we'll see now. Okay, like in different cases, how do we do the nomenclature? So some miscellaneous examples or rules. Like the see, there's one kind of compound, we call it as epoxy compound. Epoxy compounds are those compounds which has oxygen present in the ring. Okay, oxygen present in the ring, and we use the prefix epoxy for these kind of compounds. Okay, epoxy compounds are those compounds which has oxygen present in the ring. Like we have seen that one, right? Oxacyclohexane, those kind of compounds. Okay. For example, oxygen present in this ring. Okay. This compound is this bond, O single bond that we have here, we call it as epoxy bond. And first and second carbon atom, in between these two will have this epoxy bond present. So we call it as 1,2 epoxy ethane. Is it clear? 1,2. Just look at it. How do we write down the name of this? 1,2 epoxy ethane. Okay. This compound, we also call it as oxirane. Oxirane is also fine. Okay. Must keep this in mind. Now, the another example, if I show you this one. Oxacyclopropane also we can say. Oxacyclopropane also we can say. This way also we write. If, in fact, this one, this is the more common way we have. Okay, that also we can write. Now this one is 1, 2, 3 carbon we have, right? So it is propane. So 1,2 epoxy propane. If you have this compound, carbon, 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 and carbon, and here we have oxygen present, then 1, 2, 3. This is 1,3 epoxy butane. Did you get it? In this way, suppose if you write down the name of this, okay, this is 1, 2, 3, 4, 5. So in this way, if you write the name of this, we have seen this oxacyclohexane. In this way, if you write, it is 1, 5 epoxy. 1, 5 epoxy. What should we write? Tell me. What? Pentane or hexane? It's not hexane. You see here. We are counting only carbon atom here. Butane, propane and all. So carbon atom is 5 here. So epoxy pentane. This is the difference we have. Correct? So this is one kind of nomenclature we have. Okay? You must keep this in mind, the epoxy compound. Now, like I said, there are few miscellaneous rules we have here that we'll also see. Write down one note. Write down one note. And this you have to keep in mind. Write down if carbon containing functional group. No, it's not cyclo, it's simply pentane. It's not cyclo, Shraddha. For pentane, we have used epoxy term over there, cyclo group. Epoxy means only we have a cyclic ring there. So cyclopentane we won't use. We simply write number of carbon atom pentane. Correct? That's why I said it's a miscellaneous example we have. We have some different kinds of naming we have here. Correct? Okay. One note you write down. No, that is not there, Kiran. Epoxy and cycloalkane won't be there. Two way we can do this. I have already shown you that. Okay, oxacyclohexane we can say, or we can write epoxy alkane like that. Okay, one note you write down. First point. If carbon containing functional group is directly attached with the ring, if carbon containing functional group is directly attached with the ring, then we use following suffix. Okay, if carbon containing functional group is directly attached with the ring, then we use following suffix. Write down this. COH is carboxylic acid, CHO is carbaldehyde. If you use COCl, then it is carbonyl chloride. If it is C double bond O, OET, then it is ethyl. Since we have ET here, so ethyl carboxylate. If you have CN, then it is carbonitrile. So this suffix we use when the carbon containing functional group, all these functional groups are directly attached with the ring. Okay, directly attached with the ring. Carbon containing functional group directly attached with the ring. We use this suffix. Clear? Done. Now you see examples on this. Just a second. Okay. First point, write down. If carbon containing functional group is directly attached with the ring, then we use following suffix. Okay. This is for carbon containing functional group. You must keep this in mind. Okay. Now you see some examples here. Suppose we have this compound COOH. COCl. CN. CHO. C double bond O, OME. The name of this compound is cyclobutane. Carboxylic acid. Why this suffix? We are not using oic acid here because it is directly attached to the ring. Hence we use suffix carboxylic acid. Okay. For this one, it is cyclobutane. Again, you see, we are not writing it down cyclobutyl. Cyclobutyl, we are not writing. Cyclobutane, carbonyl chloride. This one is cyclopropane, carbonitrile. Simple one. This one is cyclopentane, carbaldehyde. This one is methyl, cyclopentane methyl carboxylate. Sorry, cyclobutane methyl carboxylate. Did you understand this? Done? If you have any double bond, hello? What one? Which one is Shruti? Number 2 functional group having carbon atom. What, I didn't get you? This functional group COCl will have one carbon atom here. Did you understand this, all of you? Correct. Now, point number 2, we write down into this. Rule number 2, another rule, write down. Write down, if more than two carbon containing functional group if more than two carbon containing functional group is directly attached, more than two carbon containing functional group is directly attached are directly attached with unbranched alkane then we consider the alkane as the parent chain, principal carbon chain, parent chain. Okay. Again, I am repeating, if more than two carbon containing functional group are directly attached with unbranched alkane, then we consider alkane as the parent chain. Okay. So for example, you see this, if you have this compound, okay. So these are the carbon atoms we have, 3 carbon atoms, and more than 2 carbon containing functional group is attached with this chain, right? With this chain, more than 2 carbon containing functional group is attached. In this case, we won't consider this as the like this carbon in the parent chain. We'll start numbering from here, 1, 2, and 3. Another rules we have. No, it's not. Right? 1, 2, and 3. So it is propane, one comma 2 comma 3 tricarboxylic acid. This is the name of this compound. And that is what the rule is. If more than 2 carbon containing functional groups are directly attached to the unbranched alkane, then we consider alkane as the parent chain. Because that is not the rule, Shraddha. Otherwise, there is no any point of having prefix of COOH. No, it's not. See, what is the rule I gave you just now? Rule is what? Carbon, more than 2 carbon containing functional group directly attached to the chain. Then we consider the alkane as the parent chain. This is the parent chain. We do not consider these groups in the parent chain of this molecule. Even if you have molecules like this, that is what the rule of IUPAC we have. Suppose this one, CHO, CHO, and CHO. Again, for this one also, the parent chain is this 1, 2, and 3. And the rule is propane 1, 2, 3 tricarbonaldehyde. That is what you have to do. Okay, we are following the rules only in this chapter from beginning to end. You are not accepting it since this is new for you, right? But from the beginning to end, if you see, we are following rules only here, because that is not the rules, Shambho. That is what I'm talking about from the past 10 minutes. We are following rules, and the rule says that in this case we cannot write oic acid since we are not considering COH into the parent chain. Now, why this rule we have? There are many reasons for that. We have given rules for the naming of each and every organic compound, right? So if you consider that into the parent chain, right, carboxylic acid into the parent chain, then maybe for other compounds this thing won't be true, right? For other compounds, because the rules for whatever it is given, it is based on the various study research which has been done by the different scientists, right? Hence there are various rules, okay, and that is what we are following here. It's the same thing here. That's what I have given you. Note point number 1, and this is the point number 2. Carbon containing functional group directly attached to the open chain. Then suffix is that only that I have written. I've given you. Suffix will be that only. But the parent chain will be the unbranched alkane. Right? Unbranched alkane. So that is how the rule is. Suffix will be the same that I have given you. That is why I have told you in the beginning. Some miscellaneous examples, some different examples we'll see, which does not follow the rules, the normal rules that we have. Okay, you have to take this as it is. Same thing they have asked in JEE exam. Even in NEET also they have asked these exams, these questions. Okay, this example you see, could you tell me the name? Pentane 2, 3, 4 tricarboxylic acid. Very good. This one is correct. Pentane 2, 3, 4 tricarboxylic acid. What about this one? In this one thing you see, we'll write this triethyl first. Triethyl propane 1, 2, 3 tricarboxylate. This is the name of this compound. Done? Understood? Yeah, correct. Now, write down the heading, nomenclature of aromatic compounds. What is this compound? This compound is benzene. I'll draw few structure first to see. Okay, this compound is hydroxybenzene. We also call it as phenol. Right. Yes, yes, yes. This molecule and this molecule are same. These two are same. Both are benzene only. Why we have this? What is the meaning of this? We'll discuss this later. Okay, but these two are same. This is phenol. We also call it as hydroxybenzene. NH2 is the name of this compound is NH2 on benzene ring. It is aniline. Aniline. Aminobenzene. This one is benzene carbaldehyde, or we also call it as benzaldehyde. Benzene carbaldehyde, benzaldehyde. COOH on the top, it is, write down here, it is benzene carboxylic acid or benzoic acid. Benzene carboxylic acid or benzoic acid. CN on the top, it is benzonitrile or benzene carbonitrile. Benzene carbonitrile or benzonitrile. Okay. Now, if you have this benzene ring and one halogen atom attached to this ring, X halogen atom. So it is halobenzene, benzene, and we also call it as aryl halide. Aryl halide. What is the name of this compound? This is methyl benzene. NO2 on the ring. It is nitrobenzene. Okay. One more. On the ring, if you have OCS3 attached, OCS3 is methoxy group. It is methoxybenzene. Right? So all these groups we have discussed, which is directly attached on the ring. Okay. Did you finish this? Done? Finished? Now, write down one note here. If the side chain contains, write down, if the side chain contains functional group, if the side chain contains functional group, then benzene is known as phenyl. If the side chain contains, if the side chain contains functional group, then benzene is known as phenyl. Done? Okay. So for example, you have a ring and on the ring, this group is attached. So when this group is attached, see this side chain contains one functional group, that is OH, hydroxy, correct? So it means this becomes the parent chain of the compound, and this becomes the substituents. Substituents, correct? Parent chain and substituents. No, it's not. How could I remember what I was talking about before 5 minutes? What happened, Kiran? Or maybe some network connection. I'll repeat the rule. The rule is, the rule is, if the side chain consists of functional group, if the side chain consists of functional group, then the benzene is known as phenyl. The benzene ring is known as phenyl. When you write down the name, we'll use the word phenyl, not benzene. Correct? Now, based on this rule, we have this example. This is benzene ring, and this is side chain contains functional group. What doubt? Yes. Let me do this, wait. So this contains this functional group. So this is the parent chain, and these are substituents. So the name is, we'll start numbering from here. 1, 2, 3. 1 phenyl, propane, 1 all. Now it's the same thing. Just we have to use the word phenyl. No, it's not. It's not that. No, it's not that, Kiran. It's not that. That is something else. No, it's not that phenyl. Okay, right? It's the name of this phenyl group. Okay, phenyl ring, we call it as. Okay, you understood the rule? Tell me the name of this compound. CH2, NH2. It is phenyl methenamine. Yes or no? Phenyl methenamine. What is the name of this compound? Tell me the name of this one. Yes, 2-phenyl, not only phenyl, because this is the chain we have. So 2-phenyl ethanoic acid. This one, NO2 has more preference over this. So numbering will be this. And the name of this compound is 2-bromo, 4-chloro, 1-nitro, benzene. 2-bromo, 4-chloro, 1-nitro, benzene. NO2 has more preference. Done? All of you understood this? Clear? Tell me quickly. Okay. The last two things for this chapter we have, and that is nomenclature of spiro and bicyclo compounds. Okay, nomenclature of spiro and bicyclo compounds. Spiro compounds, write down. These are the compounds in which the two rings are joined together. Compound in which the two rings are joined together with a quaternary carbon. Okay, two rings are joined together by quaternary carbon, right? How to name these compounds, I will explain this with an example. Okay, so all of you listen to me carefully. It's not that tough. Just 2 points you have to keep in mind. Suppose we have this compound. This is the compound we have, suppose. So is this a quaternary compound? Sorry, spiro compound? Yes, it is, because the two rings, one is this one, another one is this, joined together by a quaternary carbon. No doubt. Okay. So the name of this compound, if I have to write, I will write down first of all spiro. So we use spiro prefix for these kind of compounds. Spiro prefix for this kind of compounds. Here we write down some numbers separated by dot, not comma. Right? And then here we'll write down the total number of carbon atom in this compound. That is 1, 2, 3, 4, 5, 6, 7. So heptane. Right? Heptane. Right? This is the common form of this naming of this compound. Spiro prefix, square bracket, and then the root word. Right? If any substituents is there, we also write down like 2-bromo, spiro, this, heptane, like that. Okay, we'll discuss that also. But the numbering of this ring, that is very important to understand. It's simple. Numbering, how do we do? This carbon, the common carbon that we have here, we won't include this into numbering first. Okay, we won't start numbering from this carbon. That is one thing. Okay, we start numbering from the adjacent carbon of this. Right. So how many adjacent carbon we have for this carbon? Could you tell me how many adjacent carbon we have for this common carbon? We have 4, right? Yes, correct. We have 4 adjacent carbon, 1, 2, 3, and 4. So in spiro compound, we'll start numbering from the smaller ring, right? From the smaller ring. Okay, all these things you write down in your own words. So this is 1, this is 2, now this becomes 3. We cannot jump this. Okay, so 1, 2, 3. If this is 3, we can take 4 as this carbon or this carbon, any one. So suppose it is 4, 5, 6, and 7. Correct? Now here we write down the number of carbon atom here in the 2 ring, excluding the common carbon. In this carbon, we don't have to count for the 2 ring. Except this, we count the number of carbon atom in the 2 ring and write down the number here in ascending order, right? In ascending order. So a smaller ring, if you leave this carbon, we have 2 carbon atom here, so 2, and if you leave this carbon, the larger ring, we have 4 carbon atom here, 2 and 4. These numbers here must be separated by a dot. Comma, if you write, you will get it wrong. Your answer will be wrong, right? So this is the number we have. We must write this number. So this is the name of this compound. Yeah, I'll repeat just a second. Okay, so 2 points you have to remember. Numbering starts from the smaller ring. From the smaller ring. Okay. So we start from here 1, 2, 3, 4, 5, 6, 7. So spiro, open bracket. In this, we write down the number of carbon atom in the 2 ring, except this carbon. We won't count this carbon here. So if you see this 3-membered ring, if we do not count this carbon, we have 2 carbon atom. So 2, 4 carbon atom. So 4, 2.4 heptane it is. Correct? Spiro 2.4 heptane. Could you do this? What is the name of this compound? What is the name of this compound? Spiro 2.2 butane. Always numbers are separated by dot, not comma. So the name of this compound is Spiro 2.2 pentane. Total carbon atom is 5, so we'll write down pentane. What is the name of this molecule? This one. We'll start numbering from here. 1, 2, 3, 4. Now you see, if you give this carbon as 5, then this one will be 5, 6, 7th position. We have the double bond. So we'll give this 5, 6, 7, and 8. Name is spiro, open bracket, 3.4 oct 5 in. Correct? Understood, Dhruti? No doubt? Okay. Now in this only, if I do one change here, if I place bromine over here, bromine attached at the fourth carbon here. So first we'll write the substituents here. So it is 4-bromo. Then is spiro 2.4 heptane. Clear? Easy? Correct. Understood? Fine. Now the last thing is bicyclo compound. Write down bicyclo. Write down, these are the compounds in which the two rings are attached together. The two rings are attached together with 2 carbon atoms. Right? In which the two rings are joined together by 2 carbon atoms. Okay? So now you see this example. Now it is mentioned over here that this is the point with which the two ring has been joined. These are the points. Okay? So these 2 carbon atom, we call it as, these 2 carbon atom, we call it as bridgehead carbon. Okay? This is bridgehead carbon. First thing is this. Okay? This is bridgehead carbon. Okay? And there are 3 bridges over here. One bridge is this carbon bridge, another one is this carbon bridge, and another one is this carbon bridge. Okay, so understand this like a bridge. However, it is a 2 ring attached with these 2 carbon atom, but they take this as a bridge. Okay, so here we have 2 carbon bridge, 2 carbon bridge. C stands for carbon here, so 2 carbon bridge. This is 1 carbon bridge. And this is again a 2 carbon bridge. Okay. So when we write down the name of this compound, we'll start with the prefix that is bicyclo. Bicyclo, again open bracket, and the total number of carbon atom here. Okay. Here we have reverse order of that. We'll start numbering from the bigger ring. Okay, so numbering starts from the larger ring. First point is that. Larger ring. Okay. And then total number of carbon atom. With that, we'll write down the root word. So 1, 2, 3, 4, 5, 6, 7. So here we get heptane. Here we'll write down the number present in the two ring, the number of carbon atom in the carbon bridge, whatever the number of bridge you have. We have 3 bridges here. Number of carbon atom in the bridge in descending order. Reverse of that. Number of carbon atom in the bridge in descending order. So you see the carbon atom here we have, in one bridge we have 2 carbon, another bridge we have again 2 carbon and only 1 carbon. So it is 2.2.1. Remember the numbers are always separated by dot. You cannot use comma here. Okay. So this is the name of this compound. Try this one. So the key thing is what? Numbering starts from the larger ring, and here the number should be in descending order. In spiro, numbering starts from the smaller ring in spiro, and the number here is in ascending order. See what we have to do. This carbon, we have 2 carbon bridge, 1 carbon bridge, and 2 carbon bridge. Bridge of these 2 bridgehead carbon atom that we have. So it is a bicyclo compound attached with 2 carbon atom. So we'll write bicyclo, open bracket, and total number of carbon atom gives you the root word here. That is 7. Now here the number we'll write here. The number is the number of carbon atom in the bridges. Like we have 2 carbon atom here, 2 carbon atom here, and 1 carbon atom. Basically, we have to see with what value of carbon atom, what number of carbon atom, the 2 bridgehead carbons are attached. So it is 2, 2, 1, 2.2.1 heptane. Now, to try this, I think you will get it. This one you see. Tell me the name of this compound. This is the 2 carbon we have here. Bridgehead carbon is this. So this one is bicyclo. Then numbering will start from here. And one more thing, that the numbering will start from the bridgehead carbon. From bridgehead carbon towards the larger ring. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? From the bridgehead carbon towards the larger ring. So it is 4.3.0 nonane. Zero also will write. Bridgehead, there is no carbon atom here, so we'll write 0. 4.3.0. We'll see this example also. Okay. This is the carbon attached bridgehead carbon. We'll start numbering from here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is 2 bromo. Bicyclo. 4.3.0. No name. Okay. This example you see. And we have double bond O here. You see 1, 2, 3, 4, 5, and this is 6. In the last, we'll do the bridgehead carbon, this carbon, right? Done. So for this one again, you see bicyclo, open bracket, 1, 2, 3, 4. Okay, so we have 2.1.1. Just a second. So it is bicyclo 2.1.1 hexane 2 ohm. Understood this? The last two. The name of this one, this one is 1, 2, 3, 4, 5, 6, 7. So the name is bicyclo 3.2.0 heptane. This one is bicyclo 2.2.2 octane. Clear, guys? Understood? No doubt? All of you, please reply. You can type CLR, all of you guys, if you get it. Okay. So, see in the last one, what happens? We have the two ring, this ring and this ring, attached with this two carbon atom. Means you see these two carbon atom is in the plane which is above this screen. It is coming out of the plane actually. This two bond is coming up and this is in the plane. Two carbon atom here, two carbon atom here, two carbon atom here. So bicyclo 2.2.2. Clear? So this is it guys for this particular chapter. Okay, we are done. We have done so many examples in this. Okay, So next class we'll start with the first chapter of physical chemistry, that is mole concept. Some basic concepts of chemistry, mole concept. I will share some more assignment PDF with you on this nomenclature. You can solve those also. Okay. Yeah. Thank you guys. Thank you so much. Bye bye. Take care.